All right, students, so today we are working on Chapter 2, Lesson 5, which is multiplying decimals. In our textbooks, we should be on page 86. So go ahead and pause and get there. Our learning target today says I can find the product of a whole number and a decimal and find the product of two decimals. I'm actually going to shorten that up just a little bit and say I can find the product of two or more decimals. So the last few lessons we've been focusing on fractions. The last lesson we did adding and subtracting decimals. Now we're multiplying decimals. So the key ideas here at the very top of 86 for multiplying decimals. Put that heading there. Now, when we add and subtract decimals, you actually have to keep the decimals lined up perfectly. When we multiply decimals, we don't have to do that. So you do not have to keep the decimal lined up in order. So that's the first thing we're going to put down. We don't have to line up the decimals. That's important to note. And the second thing we need to be able to do is count how many decimal places are in the question, and that's what we use in our answer. So we need to count the decimal places in the question and use that in the answer. So those are the key ideas, and that'll make more sense as we get into our examples. We'll talk about it again. So moving on to example 1, still looking at page 86 in our textbooks. Example 1 has two parts. We're going to be multiplying decimals and whole numbers to start off with. So the first one says find 6 times 3.91. We're going to write it out exactly how they did it. And now we're going to decide how to write this up and down horizontally. So if you look at the 6 only has one digit. The 3.91 has 3 digits. Because it has more digits than the 6, even though it's a smaller number, we're going to put 3.91 on the top of our multiplication sentence. Remember, we don't have to line up the decimals, so we didn't have to put the 6 underneath the 3 holes. Now we're going to multiply as if there was no decimal in the problem. 6 times 1 is 6. 6 times 9 is 54. 6 times 3 is 18, plus 5 more would give us 23. Now here's where the second little key idea comes in. I'm going to count the decimal places in the question. Here's my decimal. I have 2 decimal places after the decimal. So we have 2 decimal places after the decimal. That tells us down here in our answer, we're going to move the decimal in or to the left 2 spots. So our final answer here will be 23.46. So you count how many decimal places you see up here. That's how many times you move it to the left in our answer. Doing that again with example 1b, they give us 3 times 0.016. So if we look, 3 has 1 digit, and we're not going to count the zeros as digits. The 0.016 has 2 non-zero digits. So since 2 is bigger than 3, we're going to put this number on the top. So we're going to go ahead and put 0.016 times 3. Notice how I didn't have to put the 3 holes underneath the 0. Now we'll multiply as if the decimal weren't there. So we're going to pretend that this front part is not even there and just basically times 16 times 3. 6 times 3 is 18. 3 times 1 is 3, plus 1 more would be 4. So now we're going to go up to that second key idea again and count how many decimal values we have. I see 1, 2, 3 after the decimal place, so we're going to use 3 in our answer. So I'm going to move my decimal in 1, 2, and I'm going to go one more time. My decimal is going to go there. Any empty slots you have are going to be put in a 0. So I'm going to have a decimal, a 0, and 4, 8 in my answer. We can always put a 0 in front of the decimal. That doesn't change our number. So my final answer to this one is 0.048. So that's how we multiply a whole number with a decimal. Still looking at 86, example 2 is asking us to use mental math, talking about numbers that have a 1 in the front with zeros after it, like 10 and 100 and 1,000, and what we're going to do there. So we'll switch colors and take a look at example 2. Okay. Reading the problem, it says, how high is a stack of 100 dimes? And if we look at the left, there's a picture of a dime, and it says that one dime is 1.35 millimeters high. If we want 100 of those, we're basically going to be multiplying 1.35 times 100. So we're going to write out the question. How tall is or are a stack of 100 dimes? That's the question. They tell us that one dime is 1.35 millimeters tall. So basically we're going to go 1.35 times 100. Now instead of solving like we did before, we're going to talk about a little trick that you can use when you have a number like 100, a 1 in the front with the zeros on the end. So the trick is, if you count how many zeros there are in this, that's going to tell you how many times to move the decimal over here in our first answer. So we can say over here, 100 has 2 zeros. So move the decimal 2 places. So if I take my 1.35, I'm going to move the decimal to the right this time, 2 places. If I move it to the right 2 places, 1, 2, it's no longer in between the 1 and the 3, it's now behind the 5. So my number becomes 135. And that would be my answer to 1.35 times 100. So how tall is a stack of 100 dimes? It's 135 millimeters tall. And that only works when you have a number like 100 or 1,000 or 10,000, a 1 in the front and a bunch of zeros in the back. If you've got some extra time or need some extra practice, the bottom of 86, there are 5 on your own questions. Pause and try those now. Okay, our answers to those on your own questions. Number 1 is 98.4. Number 2 is 72.55. Number 3 is 7.92. Number 4 is 0.03. And number 5 is 1,750 millimeters. Glancing over at page 87, there's another key idea here. It's about multiplying decimals by decimals. It says, multiply as you would with whole numbers. Then add the number of decimal places in the factors. The sum is the number of decimal places in the product. So the only difference here is that both our numbers are going to be decimals, which then tells us there's going to be more decimal places in our answer that we're going to have to use. So let's set up example 3. Example 3 is an A and a B. We're multiplying decimals by decimals. The first one says multiply 4.8 times 7.2. I'm going to look at both my numbers here. 4.8 has 2 digits, 7.2 has 2 digits. So now I'm going to look at which number is bigger. 7 is bigger than 4, so I'm going to put 7.2 on the top, 4.8 on the bottom. And we're going to multiply. Now our decimals happen to be lined up here, but remember they don't have to be if you don't have both being 2-digit numbers. So if we go ahead and multiply these, we have 8 times 2, which is 16. So we carry the 1. We have 8 times 7, which is 56, but we have to add the 1, so we have 57. So now I've gotten my 1 taken care of, I've done my 8s, and I have to put a place value holder in my 1s column. I'm going to move on to multiplying my 4s. 4 times 2 would give me 8. 4 times 7 would give me 28. Now I'm going to add up my two rows. 6 plus 0 would be 6. 8 plus 7 would be 15, so I'll carry the 1. 8 plus 5 plus 1 would give me 14. 2 plus 1 would give me 3. Now we're not quite done. We have to check and see how many decimal places there are in the question. We have 1 here and we have 1 here. So altogether we have 2 decimal places. So we're going to move the decimal over 2 spots in our answer. 34.56 will be our final answer. Question B, similar to that one, it says 3.1 times 0.05. If we're looking at 3.1, it has 2 digits. If we're looking at 0.05, it only has 1 non-zero digit. So we're going to put 3.1 on the top and multiply it by 0.05 on the bottom. And I don't have to have my decimals lined up. The zeros in the front don't really mean much at this point, so we're just basically going to be like multiplying 31 times 5. 5 times 1 is 5. 5 times 3 is 15. Now we have to add up our decimals. After the decimal, there's 1 value here. After the decimal, there's 2 things here. So a total of 3 values that I'm going to move my decimal to the left by. 1, 2, 3 spots. So I have a decimal, 1, 5, 5, and I can put a 0 in front. So my final answer is 0.155. Okay, go ahead and try the next set of on your own, 6, 7, 8, and 9 at the bottom of page 87. Pause the video if you'd like, and your answers will come in just a moment. Okay, answers. Number 6 is 45.36. Number 7 is 24.408. Number 8 is 0.5688. Number 9 is 0.3570. Okay. We go ahead and turn the page. We're going to look at page 88 next. Page 88 has example 4, and it's called Evaluating an Expression. So this is going to have multiple steps in it. So kind of gives us an idea that we're going to be looking at Pemdas. It says, what's the value of 2.44 parentheses 4.5 minus 3.175? So let's write it out. 2.44 parentheses 4.5 minus 3.175. There are choices here, so we can list those choices. And basically, we're going to solve this and then just figure out what choice is correct. So we have our choice A is 3.233. Choice B is 3.599. Choice C, 7.805. And choice D is 32.33. That's an interesting choice. That one looks way different than the rest, so that's interesting. First thing we need to do is subtract. And remember, when we subtract, we do have to keep the decimals lined up. So we'll go ahead and line these up. We have to start with the 4.5. We're going to subtract 3.175. So this brings us back kind of to our last lesson. Those empty spots need zeros. So we're going to go ahead and subtract these two. We have to cross this out and borrow. Oh, we can't borrow there, so we're going to cross this out and borrow from the 5, making that a 4. That borrowed one is going to go here, making this a 10, but we need one of those to make that a 10. So now we have 10 take away 5, which gives us 5. We have 9 take away 7, which gives us 2. 4 take away 1, which gives us 3. Our decimal stays lined up because it's subtraction. And 4 take away 3, which gives us 1. So the inside the parentheses here, which is where we need to start, would give us 1.325. Remember, if there's nothing in between here, we're going to be multiplying. So 2.44 multiplied by 1.325. If we look, there are 3 digits here and there are 4 digits here. I'm actually going to put the 4-digit number on the top this time and the 3-digit number on the bottom. It'll make our multiplication a little easier, a little less confusing. So we have 5 times 4, which is 20. Then we have 4 times 2, which is 8, plus 2 more, which is 10. Then we have 4 times 3, which is 12, plus 1 is 13. Next we have 4 times 1 is just 4, plus 1 is 5. Now let's go to our next row. So we tick, tack, toe. 4 times 5, which is 20 again. 4 times 2, which is 8, plus 2 is 10 again. 4 times 3, which is 12, plus 1, which is 13 again. 4 times 1, which is 4, plus 1 is 5 again. So basically just shifted all of our numbers over, added a 0 at the end. So I've used all of those. I've used that. Now I have to put 2 zeros as place values. 2 times 5 is 10. 2 times 2 is 4, plus 1 would give me 5. 2 times 3 is 6. 2 times 1 is 2. Now I will add up my 3 columns. We have a 0. We have a 0. We have a 3. 5 and 5 plus 3 is 13. 6 plus 5 plus 1, which is 12. 3 plus 1, which is 3. So now look up here and figure out how many decimal values I have. I have 1, 2, 3 in this row. And there's my decimal here. I have 1, 2 in this row for a total of 5 times I'm going to move my decimal. 1, 2, 3, 4, 5. So my final answer is 3.233. If you want to put the double zeros on the end, you can, but it doesn't change your number if you don't put them on there. So our final answer would be A, 3.233. Last example for the lesson is example 5, looking at the same page in our books. Switch colors. Lesson 5 is that real-life application. It says you buy 2.75 pounds of tomatoes. You hand the cashier a $10 bill. How much change will you receive? So if you look at the pictures, it's looking at tomatoes, grapes, and bananas. The question is actually only talking about the tomatoes, so we really don't care about the grapes or banana prices at this point. It says tomatoes are $1.89 a pound, so we're going to use that information. Let's go ahead and pull out some important pieces here as we write out example 4. First thing they tell us is that it's 2.75 pounds of tomatoes that we want. We also know from the sign in the picture that it's $1.89 per pound. And we give a $10 bill. We want to know what is going to be our change. This is going to be a couple of steps as well as the last problem was. So our first step is going to be taking our 2.75 pounds of tomatoes and multiplying it by 1.89 per pound. So 2.75 is larger than 1.89. So 2.75 is going to go on the top. So when we do this multiplication, we have, this is a 9. Make that a little bit more clear. We have 9 times 5, which is 45. Then we have 9 times 7, which is 63, plus 4, 67. 9 times 2 is 18, plus 6, which would give us 24. We have crossed out those, and we need a place value holder. 8 times 5 gives us 40. 8 times 7 is 56, plus the 4 would give us 60. 9 times 2 is 18, plus 8 times 2 is 16, plus the 6 is 22. I almost started using my 9 again. So we've used our 6 and our 4 and our 8. So now we need 2 place value holders. 1 times 5 gives me 5. 1 times 7 gives me 7. 1 times 2 gives me 2. So now we have to add up our 3 rows. Here we've got a 5, 7. 5 plus 4 would give us 9. 7, 2, and 2. 11. 2, 2, and 1. 5. Looking at the question, figuring out how many place values I have in my decimals. I have 1, 2 here. I have 1, 2 here for a total of 4 moves. 1, 2, 3, 4. So if I'm talking about dollars here, I'm going to round this to dollars and cents. So it looks like I'm going to have $5 and 0.1975 is about 20 cents. So I'm going to round this off to about $5.20 total that I have to pay. Now, if I give a $10 bill, I have to take that $10 bill and subtract $5.20. Notice how now that we're subtracting, we lined up our decimals. 0 take away 0 is 0. I can't use those, so I borrow the 1, making this a 10. I borrow that, making this a 9 and this a 10. 10 take away 2 is 8. Keep my decimals lined up. 9 take away 5 would be 4. So if I give a $10 bill, my change would be $4.80. That brings us to a close on our lesson. We have one more on your own at the very bottom of 88, number 12. Pause the video if you don't want to hear the answer. Okay, the answer to that is 52 cents. This is 0.52. And that brings us to the end of Chapter 2, Lesson 5.